Advanced trigonometry. So I just want to review a few basics very quickly before we jump into the problems. First, SOHCAHTOA. This is a mnemonic that you're probably familiar with. If we look at this triangle here and we focus on angle A, then we see that the sine of A is opposite over hypotenuse. The cosine of A is adjacent over hypotenuse. And the tangent of A is opposite over adjacent. You should know your two special triangles, the 30, 60, 90, as well as the 45, 45, 90 triangle. Notice that a 45, 45, 90 triangle is also an isosceles right triangle because it has two sides that have the same length, the two legs. The cofunction identities are very important. They come up all the time. So sine 90 minus x equals cosine x, and cosine 90 minus x equals sine x. These look a little mysterious when written down, but geometrically they make perfect sense. All they're saying is that if you look at the triangle here, the cosine of angle A is equal to the sine of angle B, because the measures of angle A and B add up to 90 degrees. And similarly, the sine of A is equal to the cosine of B, right? Because if A has measure x, then B has measure 90 minus x, and vice versa. Then we have the negative identities. For example, cosine of negative x equals cosine x. Those of you familiar with even and odd functions will recognize this is saying that cosine is an even function. And similarly, sine and tangent are odd functions. Sine of negative x is the negative of the sine of x, and similarly for tangent. Then we have the main Pythagorean identity, which says that cosine squared x plus sine squared x equals 1. And one other thing that's going to come up are these Pythagorean triples. They're worth knowing because they'll save you some time. 3, 4, 5, and 5, 12, 13. So a right triangle with legs of lengths 3 and 4 has a hypotenuse of length 5, and similarly for 5, 12, and 13. Okay, let's jump into some problems. One thing I'd like to point out, this little number on the upper right, that's the level of difficulty of the problem. The level goes from 1 to 5, 5 being the hardest, and we're going to start at a medium level, level 3 problem, and work our way up to harder problems. Okay, in a right triangle, one angle measures x degrees, where sine x degrees is equal to 3/8. What is the cosine of 90 minus x degrees? Okay, well, we're going to use the cofunction identity. In particular, this one, that cosine 90 minus x is equal to sine x. So let me just rewrite cosine 90 minus x degrees. Well, by the cofunction identity, that's equal to sine x degrees, which we know is equal to 3/8, giving us answer choice B. Very quick and easy if you remember the cofunction identity. Just in case you don't remember the cofunction identity when you're given this problem, let's do an alternate solution that doesn't require it. So for that, I'm going to draw a right triangle and label the sides using SOHCAHTOA. So in this case, sine is opposite over hypotenuse. So the sine of x is opposite 3 over hypotenuse 8. Okay, now y here is 90 minus x, right? So if this angle is x, then the other one that's not the right angle is always 90 minus x. So cosine 90 minus x is the cosine of what's written there as y. And using SOHCAHTOA again, cosine is adjacent over hypotenuse, right? Cosine is adjacent over hypotenuse. So that's equal to 3/8, which again is choice B. Which of the following is equal to cosine of pi over 5? Okay, this looks pretty difficult when you look at it, but if you know your cofunction identities, you could do this pretty quickly. Notice I'm going to rewrite the cofunction identities in radians instead of degrees, right? So 90, I'm going to replace by pi over 2 radians, right? 90 degrees is pi over 2 radians. And I'm going to go ahead and write cosine pi over 5. And using this first cofunction identity here, we see that that's equal to sine of pi over 2 minus pi over 5. Okay, so we do have to do just a little fraction work here, right? Getting a common denominator of 10, if we multiply pi over 2, the top and the bottom by 5, that becomes 5 pi over 10. And if we multiply the top and bottom of pi over 5 by 2, we get 2 pi over 10. And now it's very easy to subtract those to get sine of 3 pi over 10, which is choice C. Suppose that k is between 0 and 90, and t is between 0 and 90, and cosine k is equal to sine t. If k is 1/3 z minus 42 and t is 2/3 z plus 12, what is the value of z? Okay, so let's start with cosine k equals sine t. That implies, using the fact that k and t are between 0 and 90, that k plus t must be equal to 90. Now, if you know that and you want to accept that, that's great. But let's just look at why that's true really quick using the cofunction identities. So just recopying cosine 90 minus x equal to sine x and replacing x by t gives us cosine 90 minus t degrees is equal to sine t degrees. And look at that, sine t is equal to cosine k. So we can replace sine t with cosine k to get cosine 90 minus t is equal to cosine k. And since k and t are both between 0 and 90, that means that 90 minus t has to be equal to k. And if we just add t to each side of that equation, we get that k plus t has to be equal to 90. Okay? So now we really just have to do some algebra. In place of k, I'm going to plug in 1/3 z minus 42. And in place of t, I'm going to plug in 2/3 z plus 12. And now let's go ahead and combine like terms on the left-hand side. Right, 1/3 z plus 2/3 z is 3/3 z, or just 1 z, which we could just write as z. And negative 42 plus 12 is negative 30. So we get this very simple equation, z minus 30 equals 90. Adding 30 to each side of that equation gives us 120, which is the value of z that we're looking for. In triangle DOG, right? Triangle DOG, DOG, the measure of angle D is 60 degrees and the measure of angle O is 30 degrees. If line segment DO is 8 units long, what is the area in square units of triangle DOG? Okay, well, let's start by drawing a picture of triangle DOG, right? We have here DOG. It says the measure of angle D is 60 and the measure of angle O is 30 and DO is 8 units long. So I just labeled everything there. Okay, and that's a 30, 60, 90 triangle. So hopefully you remember this, or you could look it up. The 30, 60, 90 triangle in terms of a general x, right? We see here, look, we have an 8 here, a 2x here, right? So 2x is equal to 8. Which means that x is equal to 4. And right, that's right there. So x is the side opposite 30 degrees. So we label that with a 4 in triangle DOG on the left there. And root 3 times x is root 3 times 4, or 4 root 3. So we could label side OG with 4 root 3 like that. Okay, now we want the area. Well, the area of a triangle is 1/2 base times height. In this case, that's 1/2 4 root 3 times 4, which is 8 root 3, right? Half of 4 is 2, and 2 times another 4 is 8, and we leave the root 3 as is, and that's choice D. Okay, 5. In the figure below, what is the equation of line K? All right, I'm going to start by just drawing a vertical line segment there, creating a right triangle. And that's a 30, 60, 90 triangle, right? So if this is 60 degrees and this is 90 degrees, this has to be 30 degrees. All right, so let's just label the side opposite the 30 with a 1. We could actually pick any number we want here, but 1 is a nice, simple, natural choice. And it follows that the hypotenuse has length 2, and the side opposite the 60-degree angle has length root 3. Okay, just because it's a 30, 60, 90 triangle. All right, so this point up here is the point 1 root 3, because to get to it, we move from the origin to the right 1 and then up root 3. The slope of line K is rise over run, which we could see is root 3 over 1, and that simplifies to root 3. So we have m equals root 3. And b here, of course, is 0. B is the y-intercept, or more specifically, the y-coordinate of the y-intercept, which is 0 here. And we can now write an equation of the line in slope-intercept form, y equals root 3x plus 0. And that's just y equals root 3x, which is choice D. 6. In triangle QPR below, point S, which isn't shown, we'll add it in ourselves, lies on segment QR so that PS is perpendicular to QR. What is the value of cosine angle QPS minus sine of angle SPR? Okay, without seeing the S there, this might seem a little confusing. So first, let's just make the triangle a little bigger, just so we can see everything clearly. And since we have a 60-degree angle and a 90-degree angle, the other angle has to be 30 degrees. It's a 30, 60, 90 triangle. And I'm going to go ahead and draw in point S as well as segment PS. So, right, it says here that point S lies on QR so that PS and QR are perpendicular. So we have to make sure that when we draw it, it forms right angles over here, like that. Okay, now let's go ahead and fill in the other angles. So this angle here, angle QPS, has to be 30 degrees, right? Because this is 60, this is 90, so this is a 30, 60, 90 triangle. And similarly, we have another 30, 60, 90 triangle here. So SPR also has measure 60 degrees. Okay, so now we're trying to compute cosine of angle QPS minus sine of angle SPR. Well, we could clearly see these angles now, right? Angle QPS is 30 degrees, that goes here. And angle SPR, that's here, SPR, is 60 degrees, so that goes here. And the cosine of 30 minus the sine of 60, once again, using these cofunction identities, which keep coming up, is 0. Right? Because the cosine of 30 is the same as the sine of 60, because 30 and 60 add up to 90. Seven, a homeowner drew a sketch of their triangle-shaped garden, as shown below. Although the sketch was not drawn accurately to scale, the triangle was labeled with the proper dimensions. What is the value of tan x? Okay, so here we have a figure that's not drawn to scale, but we do have some labelings. We see it's an isosceles triangle because 2 of the angles are labeled with x's, and we have 2 of the side lengths, 20 feet and 26 feet. Okay, I'm going to go ahead and draw the perpendicular from this vertex of the isosceles triangle down to the base. That's called the altitude, right? This is an altitude, but because it's an isosceles triangle, the altitude, the median, and the angle bisector are all the same. So in other words, since this segment is perpendicular, it also splits this segment into 2 equal pieces, as well as splitting this angle into 2 equal pieces. That always happens in isosceles triangles, okay? So that means that this side length from here to here is half of 20, so it's 10, right? Because this is also a median as well as being an altitude. Okay, let's just delete that 20 for now because we're not going to need it. And now we're going to go ahead and use one of our Pythagorean triples, 5, 12, 13, but we're going to have to double it, right? So 5 times 2 is 10, 12 times 2 is 24, and 13 times 2 is 26. We see we have 2 of those numbers in that triangle, and the biggest one, the 26, is the hypotenuse. So that means that the other side is 24 feet. Okay. So now we're ready to compute the tangent of x, right? Using SOHCAHTOA, tangent is opposite over adjacent. So that's equal to 24 over 10, which reduces to 12 over 5, or you could write it as a decimal as 2.4. Either of those answers are okay. 8. A ladder rests against the side of a wall and reaches a point that is h meters above the ground. The angle formed by the ladder and the ground is theta degrees. A point on the ladder is k meters from the wall. What is the vertical distance in meters from this point on the ladder to the ground? Okay, that's a lot. Let's start by drawing a picture and just trying to put all the information in one thing at a time. So here's a picture. We have a ladder resting against the side of a wall, right? And here's the ground. So now it says that the ladder reaches a point that is h meters above the ground. So that means that this length is h. And the angle formed by the ladder and the ground is theta degrees. That's here. Now, what about this point on the ladder that is k meters from the wall? There it is, right? K meters from the wall. I don't know how high it is. I'll just arbitrarily put it at this height. So it's k meters from the wall. That means this length down here is also k, right? Because this forms a little rectangle. And it says, what is the vertical distance in meters from this point on the ladder to the ground? So we want to know what this vertical distance is. Let's label that with an x. That's what we're trying to find. And I'm just going to go ahead and label this side of this smaller triangle here with a y, just so that we could talk about it as we solve the problem. All right. Now using SOHCAHTOA again, in particular tangent, you can see why I might want to use tangent here, because I have all this information. I have these sides, I have these sides. I don't know anything about the hypotenuse in this particular problem. So remember that tangent of theta is opposite over adjacent, but there are actually two choices here, right? So we could look at tangent of theta as it applies to the smaller triangle, or as it applies to the bigger triangle. And in fact, we're going to do both. Let's look at the smaller triangle first. Here, the opposite is x, and the adjacent is y. So the tangent of theta is equal to x over y. And we can multiply that equation on each side by y to get y tan theta equals x. Okay, and now we're going to do the same thing, but this time looking at the big triangle, right? So in this case, tan theta is opposite over adjacent, which is h over y plus k, right? The opposite is h, and the adjacent is y plus k. Multiplying by y plus k on each side of the equation gives us y plus k, all times tan theta is equal to h. All right, this is great. Now I'm going to go ahead and distribute and get y times tan theta plus k times tan theta equals h. And what we see here is that we now have y tan theta is equal to x, and we also have a y tan theta here, which we can now replace by x. Okay, so we have x plus k tan theta is h, and solving for x, we just subtract k tan theta from each side to get that x is equal to h minus k tan theta, and that is actually choice D. Okay, 9. In the figure below, cosine p equals 12 over 13. If RQ is equal to 10 and TQ is equal to 3, what is the length of RS? Okay, let's start by filling in a little of the information that we have. Well, we have that RQ is 10, so I'm going to label side RQ with a 10, and TQ is 3, so I'll label that there as well. Okay, and we want RS, so we want to figure out this side. Well, that seems tricky because it's not a side of a triangle, it's only a partial side of a triangle. Okay, so what I'm going to do now is use the fact that cosine P is equal to 12 over 13, and I'm just going to draw another triangle next to it and label the sides using the fact that cosine is adjacent over hypotenuse, right? Cosine is adjacent over hypotenuse. So if I write the adjacent side as a multiple of 12, 12x, then the hypotenuse has to be the same multiple of 13, 13x. Okay, and then once again, I'm going to use this Pythagorean triple 5, 12, 13, and multiply each of those numbers by x to get 5x, 12x, 13x. So we know that RQ is 5x. Okay. So now I'm just going to recopy the big triangle that we started with. I'm going to leave out the little triangle for now. And notice that I labeled it as a 10 for RQ, just like it is supposed to be. And comparing it to the triangle that we used with getting the information from cosine, we see that 5x is 10, so that x has to be 2. And that allows us to get that 12x is 12 times 2, which is 24, and 13x is 13 times 2, which is 26. Okay? All right. So now I'm just going to redraw that little triangle, and let's try to get some information about this little triangle now. Well, using the fact that PQ is 24 and TQ is 3, we see that PT is 21, right? Because PT is PQ, which we know is 24, minus TQ, which is 3, and that leaves us with 21. Okay, boy, this figure really is not drawn to scale at all, right? If you look at these numbers, which, you know, the question says it's not, so that's okay. Okay. Now, these two triangles here are similar, right? How do we know they're similar? Because they both have 90-degree angles, and they both share angle P. So once you have two angles that are congruent, or that have the same measure, you know that your two triangles are similar. Therefore, the sides are in proportion, and we could write PS here divided by 26 is equal to 21 over 24. Okay, reducing 21 over 24 we could factor out a 3, and we're left with 7 over 8. So that multiplying by 26, we get that PS is 7/8 times 26, which comes out to 22.75. Now, if you're allowed to use a calculator, just punch it in the calculator. If you can't use the calculator, I would try to reduce the 26 with the 8 first and then do the computation. It wouldn't take too long. Okay. So we can now label PS with 22.75. Now, just recopying the original triangle, we see that PT is 21 and PS is 22.75. Okay, and now using the fact that PR is 26 and PS is 22.75, we see that we could get RS by subtracting, right? So here RS is equal to PR, the whole thing, minus this little part here. So we get 26 minus 22.75, which is 3.25, and that is the answer. Number 10, it is given that cosine x equals k, where x is the radian measure of an angle, and x is between pi and 3 pi over 2. If cosine z is equal to negative k, which of the following could not be the value of z? Okay, so first thing I'm going to do is take a guess, start with choice C as my guess, and I'm going to rewrite choice C right away as negative of x minus 2 pi, right? So I kind of just interchange the negative x and the 2 pi and then factored out the minus 1, right? If you distribute this through, you see you get negative x, and negative times negative is positive 2 pi if you want to do it in reverse, all right? So we have the cosine of 2 pi minus x. Well, I'm just substituting in place of 2 pi minus x. I could put negative x minus 2 pi. And then I'm going to use that negative identity for cosine to just drop the minus sign, right? Because cosine is an even function. And then I'm going to use the fact that the cosine of x minus 2 pi is the cosine of x, right? Whenever you add or subtract the multiple of 2 pi inside an expression involving cosine or sine, you could just drop it because the cosine of x plus any multiple of 2 pi is just equal to the cosine of x. Okay, now we were given that cosine x equals k, and k is not equal to minus k. So this shows that choice C is the answer. It could not be the value of z if we were to want cosine of z to be minus k. Okay, so we got lucky. We started with choice C, which is where I always like to start, and it actually worked out to be the answer. I want to finish up with just Another possible way that you could solve this problem. Here's an alternate solution to this problem using the difference identities, in particular the difference identity for cosine, which says cosine A minus B is cosine A cosine B plus sine A sine B. And again, I'm going to start with choice C as my first guess, and I'm going to right away apply that difference identity. If you happen to know the difference identity, this is a pretty good way to do it, right? So we get cosine 2 pi cosine x plus sine 2 pi sine x. Well, the cosine of 2 pi is 1, and the sine of 2 pi is 0. So right away, that second term cancels because it's 0 times sine x, which is 0. And the first term just becomes 1 times cosine x, which is cosine x. And just as before, we know this is equal to k. That's what we're given. So it's not equal to minus k, giving us once again that choice C is the answer.